Hi, Molly. We are on page 137. We still had some room there, and the topic sort of bleeds into the next topic. So we're still dealing with complex numbers. We multiplied them and divided them yesterday. I took up the quiz, that aqua teal colored quiz. So I'll need yours when you come in. And we checked the homework on multiplying and dividing. There were 8 problems on the regular blue sheet. So let's go ahead then and look at how to take a complex number and raise it to a power. You don't have to write this down, but if you would just attend to it for a minute. This is not complex at all. It's just an old friend from the real number system way back then when we worked with real numbers, x and y. That's about as real as we got. If we raise that to a power, like 6, it'd be really sweet and nice if it was x to the 6 plus y to the 6th. But it is not. It is not. Don't try to tell me somebody in your past taught you that, because I know they did it. What this really means is x plus y to the 1 times x plus y to the 1 plus x plus y to the 1 6 times. So how long would it take us to work this out? Well, we could do the first one pretty quick. We do those 4 steps pretty much in our sleep now. But then we would have 3 answers to distribute among 2. Then we'd have 4 answers to distribute among 2, and on and on. It would take probably the rest of our class, but we could do it. We could do it. But what happens if we switch to the real, from the reals to the imaginaries? You don't have to write this down, you're just observing, since we're conserving room there. What about when we switch to a plus bi to the 6? The problem becomes no less simplified, because that means this times itself 6 times, which is multiple steps 6 times. First, these 4 steps, you'll have 3 terms times 2 and 4 times 2, and on it goes. So we could do it, but luckily, when we switch these a plus bi, this is called standard form, or sometimes you hear me call it, what do you hear me call it? Standard form or rectangular form. When you switch to trig form, and a trig form, like what's a number we've had? I think I was thinking of square root of 3 plus I. Square root of 3 plus I. If we were raising that to the 6, it'd be a big mess. But if we took the equivalent of that, we did this one in our homework the other day, 2 cosine 30 plus I sine 30, and we raise that to the 6, you'll see we can do it in a blip. It's not a long process at all. So that's why we learned this thing called trig form in the first place, to simplify our life and make our homework even enjoyable. So let's start the joy off. All right, here's our first one. Now's what I want you to write. I think I can try to draw this out of you. Is that possible this morning?
No.
To draw something out of you? No. All right, I'll try. All right, you remember how to multiply two numbers in trig form? Hannah, what do we do with the numbers out in front when we're multiplying?
When you're multiplying, you add them.
The numbers out in front.
Oh, you multiply them.
And then what do you do with the angles inside?
Them.
Right, so multiply the 2 numbers out in front and add the 2 inside. So let's take one. Suppose we are taking R1. You can write this down now. Cosine theta 1 plus I sine theta 1. Suppose I take that number, and I'm going to raise it to the 6. That was our special number today. But once I teach you this 6, you can raise it to the 2, to the 4, to the 8, or anything. So you already know that when you raise something to the 6, you're going to multiply it times itself 6 times. So don't write this down, because you are conserving. But this is where I'm going to draw it out of you. So This is where I need 6 boards, not 1.
You can't multiply that by 3.
So, what's that?
Nothing.
Okay, can't multiply it by 3? Oh, what yeah. So this means I'm going to multiply it times itself 6 times. So from what we learned about multiplication, can you do the first multiplication for me? So Abby, what do we do from yesterday? This is only the first step, but we're going to multiply this number times this number. What would that give us?
R1 times R1.
Yeah, R1 times R1, right, which will be R1 squared.
And then in parentheses, cosine theta 1 plus theta 1.
Right, which is 2 theta 1s. So I'll just go ahead and simplify.
And then plus I sine theta 1 plus theta 2.
No, everything's theta 1, isn't it? I'm sorry. My mistake.
Plus theta
Okay.
1, so
Well, you guys aren't watching. All right, 2, so theta 1 plus theta 1 is 2 theta 1s. All right, so that's, I've done 2, oops. I've done 2 of the 6. Now I'm going, this is our number squared. If I multiply it times itself again, Allie, you pick up from here. And then by then I think you'll see the pattern. All right, she's in the cube land. We had Abby did the square. This is the square. So Allie, what will happen when I multiply this number times this number?
R cubed cosine 3 theta plus I sine 3 theta.
Right.
And then if it's 6, we can
Yes. You're so much fun today.
change that to a 6.
This one's not. All right. All right, do you see the pattern? Bailey, tell me from what we've seen 1 through 3, what it would be the final answer, raising it to the 6th.
Cosine 6, or well,
What do I do with the R?
R1 to the 6.
Right?
Cosine 6 theta
Yes.
plus I sine theta.
Do you know what? Do you know what, Hannah? A guy noticed this, and his name was Demoivre, and he got the whole thing named after him. And you came up with it by yourselves. So I just think that you just missed the boat. Of course, he was a little bit older than you guys, so if you would name it after Demoivre, maybe it was cool because no one had seen it yet. And
his name was cooler than ours.
yeah, that's true. He's from France, so maybe you'll find his remains when you tool through France next week. All right, let me write it out in its glory.
Oh my gosh, it's next year.
So if you didn't get this development down, it won't matter. So I can just call that R. Here's what Demoivre said. You take a number, a complex number in trig form, and you raise it to the end. All you have to do is take the number out in front, raise it to the end, and take the angle and multiply it times the end. I can't write today. All right. There's probably a mistake in that. I found 2 as I went through. I wonder how many minutes we've blabbed on that. Does that show up over on the corner? You can tilt it.
Yeah, it's good now.
All right. Demoivre's theorem. How to raise a number to a number. Let's do one example and see if you can and apply it. Let us take our first homework. So we'll conquer 2 things with 1. So if you would switch to the spot where you're going to do the homework on this, whether it's a separate page or somewhere in that comp book, the first one we're going to do is number 78. So we'll accomplish 2. We'll practice this and we'll do the first homework. 3 cosine 150 I sine 150. And we're going to raise that to a number 4. All right, begin. All right. Work ahead of me, and then I'll call on someone to catch me up. We're trying to use Dumont's theorem.
How many problems are we gonna have? Will they all fit in half a page?
I don't know. There's 8. I don't know if you can fit them in or not. You can start on another paper, or maybe put a couple on there so you have examples. All right, Hannah, speak out loud. What are you doing with the 3? Speak out loud. Think out loud.
alright.
It's hard to speak any other way. Okay.
So I raised it to the 4th.
Okay. 3 is raised to 4. All right, Bailey, what do we do with the 150?
Multiply by 4.
Okay. Do anyone have some numbers? Allie, would you simplify some of these spots? We're multiplying the angle by 4, and we're raising the 3 to a 4. So give us one of those.
Okay. So 3 to the 4th is. Okay, it's 81.
It is. Very good. All right, 81 is the number outside. 3 times 3 times 3 times 3. So Abby, can you get us the number inside?
600.
All right, so 600 is not acceptable. I spoke about that in our homework today. We were going over that. Because it's greater than 360, we can reduce it. So we want the coterminal angle that's lower. So you subtract 360. If that's greater than 360, you subtract it again. So it's kind of fun. You put 600 in your mind or on your calculator, subtract 360, subtract 360 until you get a number less than 360. What is it? 240. I believe you're right. Did you have to subtract? You only subtracted once on this one. All right, so if it is even greater than 600, you may have to subtract multiple times.
Is that all we're doing?
No?
Like, is that? No, I mean, is that?
Yeah, that's
the
all we're
answer?
doing on that
The final
topic,
answer?
yes. Okay, so that's one example, and I think that'll get you through your assignment. That's the first of 4 that you'll have to do. So I'd like to get you done in class today because of all the other mess you have
we have a Europe
going.
meeting
So,
tonight.
what?
We have a Europe meeting tonight, a mandatory.
Okay, well, there's not much to do.
It's mandatory.
Yeah, you have to be there. You can't
What
miss it.
time is it?
7.
Oh, good lord.
Where?
It's here.
Okay.
It's up in one of these classrooms.
Okay. It's good to pull it together with all the last minute details, believe me.
I know, my mom's like, you
Actually,
should
I'm not
practice
gonna have to
packing.
reading. I wish it was.
Practice
How do you
packing, okay.
practice packing?
Well,
Just
you
You
just
just make sure everything's gonna
you
fit.
just make sure
Pack.
everything's gonna fit. But the thing is, I'm the kind of person who forgets stuff really easily.
Make a list.
So even when I make a list, I find things throughout the
All right,
days. that
Abby, we're gonna
follow.
do the next section on the next part, so you can shut that one down. Is that the